morning everyone. The name of the subject is Industrial Measuring Instrument. Myself Dr. Abhas Kanungo, I belongs to Department of Electronics and Communication Engineering, Kite Group of Institutions, Ghaziabad. This is the second lecture of Industrial Measuring Instrument. In first lecture we have seen that what are the various type of instrument that we can use in the measurement, or there are what type of errors that may be possible when we are doing some measurement. In this lecture we are going to see certain static and dynamic characteristics of an instrument and also one device or one transducer, that name is potentiometer. So, we will start from our first slide, that is static and dynamic characteristics of an instrument. Okay. So, when we talk about the static characteristics, what it defines? So, when we talk about the behavior, that if you are having certain set point value and if you on the output side you are having certain characteristics, and that characteristics define certain dynamic part, and this part is known as the steady state part. This part is known as the dynamic part and this part is known as the steady state part. That means what? When we talk about the steady state part, what it shows that a characteristics which deals with the steady state part of an system is known as the static characteristics, and the characteristics which deals with the dynamic part of that system is known as the dynamic characteristics. Okay. So, when we talk about the static characteristics, the bookish or official definition of the static characteristics is that static characteristics of an instrument are considered for instruments which are used to measure an unvarying process condition. Performance criteria based upon the static relation represent the static characteristics, or what I have told you that the static characteristics are the value or the performance given after the steady state condition is reached. What is steady state condition? When we talk about any system, we are having any set point value. After certain dynamics, we are reaching that set point value is known as the steady state condition. So, the characteristics which belongs to or which or the performance given after the steady state condition reach, this type of characteristics known as the static characteristics. And when we talk about the dynamic characteristics, or dynamic characteristics of an instrument are considered for instruments which are used to measure a varying process condition. That means what? I have given you one type of curve, in that when the response is varying with respect to time, when the response is varying with respect to time, this is time, and when the response is varying with respect to time, it is known as the dynamic part, and when the responses get constant with respect to time, it is known as the steady state part, and that part is belongs to the certain set point value of the input. Okay. So, this type of when time varying process defines the dynamic characteristics, and when the output is constant with respect to time, this type of characteristics is known as the static characteristics. Okay. So, performance criteria based upon dynamic relations represent the dynamic characteristics, because the response is varying with respect to the time. Now, there are lots of static characteristics. These are accuracy, precision, bias, sensitivity, linearity, resolution, hysteresis, dead zone, backlash, threshold, input impedance, loading effect, repeatability, reproducibility, static error. So, these are the static characteristics of an instrument. In that, certain belongs to the desirable characteristics of instrument which we want that our instrument should possess, and certain characteristics or certain, more specifically certain statistic characteristics belongs to the undesirable characteristics of an instrument which we do not want that this type of characteristics should present in our instrument when we are going for measurement, like accuracy, precision. These are certain desirable characteristics, and when we talk about the hysteresis, dead zone, these are the undesirable characteristics of an instrument. Okay. So, we will go further. Quickly we will see that what is accuracy. When we talk about the accuracy, accuracy is defined as the degree of closeness with which an instrument reading approaches the true value of the quantity being measured. If I am having certain predefined value of an instrument which it measures, or the accurate or the true value of the instrument is 0.325, certain I have told you one example, the true value of instrument is 0.325, and I am measuring that reading or that variable reading with the help of any instrument, and I am getting 0.4, 0.5, 0.6. So, 0.4 is nearer to the 0.3125, which is the true value. So, the instrument which is giving the value 0.4 is the accurate one as compared to the which is giving the value 0.5 or the 0.6. So, that will be the accuracy. And when we talk about the precision, a precision is the degree of repeatability of series of the measurement. So, the general question is what is the difference between the accuracy and the precision. So, it does not matter, my instrument may be precise, but not accurate. So, suppose that my I want to measure that reading 0.3. 0.3 is the true value of an instrument which I am measuring, and I am getting the reading. First I have taken that reading is 0.5, again I have taken the reading that is 0.51, again I have taken the reading third time it is 0.52. So, that instrument is precise because it is giving you the repeatability with respect to the time. Firstly, I have noticed that my value is 0.5, again my value is 0.51, again my value is 0.52. So, it will provide you the good precision, but it is not accurate because my true value is 0.3. So, that is the difference between the accuracy and the precision, and that is the very common question. You have already seen that in your earlier course. Now, next characteristics is bias. A bias is quantitative term describing the difference between the average of measured readings made on the same instrument and its true value. So, a bias is a quantitative term describing the which describe the difference between the average of measured reading and the true value. Okay. So, that property or that characteristics is known as the bias. Now, third one is sensitivity. It is also the one type of sensitivity, is also one type of desirable characteristics. If I am making certain change in the input, a certain proportional change should be obtained on the output side. So, if we talk about the definition, a sensitivity is defined as the ratio of change in output signal response to the change in input signal response. What I have told you that when I am making some changes on the input side, a same proportional changes should obtain on the output side. So, it is the relationship indicating how much output changes when input changes. If I am changing my input slightly and I am getting huge response in the output side, so my instrument is very sensitive. If I am making certain change in input quantity, I am getting very large change in the output side or in the output quantity. So, if I am getting the minute change on the input side and I am getting large change in the output side, so my instrument is very sensitive. So, it is the defined as the ratio of change in output signal response to the change in input signal response. Now, next one is linearity. So, a linearity is the best characteristics of instrument or measurement system. A linearity of the instrument refers to the output is linearly or directly proportional to the input over the entire range of instrument or with respect to the time. If I am having this side is my output side and this is my time, and output is linearly proportional to the input. Okay. So, if the linear curve between the input and output will observe, that is known as the linearity. So, the bookish definition of the linearity is that when the system follows the property of homogeneity and superposition, this is called as the linearity. What is homogeneity and what is superposition? If I am having output x1t, input x1t and output y1t, input x2t and output y2t, and if I am having input x1t plus x2t, then I should have output y1t plus y2t. This properties is known as the superposition. And when the input is multiplied by certain constant and output also multiplied with the same constant, then it is known as the homogeneity. Okay. So, when the system follows these two property, superposition and the homogeneity, that is called the linear system, or the basic definition is when there is a linear relationship between the input and the output, or the change in input is proportional to the change in output. This type of characteristics is called as the linearity. Now, next is resolution. A resolution or discrimination is the smallest change in the input on the smallest value that can be measured. Okay. The smallest change in the input or the smallest reading that can be measured is known as the resolution of an instrument. Now, next characteristics is dead zone. A dead zone or the dead band is defined as the largest change of the input quantity for which there is no output the instrument due to the factors such as friction, backlash and hysteresis within the system. Now, suppose I am having this is my graph, this is my output and that is with respect to time, and I am giving some input, but I am not getting the output. I am giving some input, but I am not getting the output, and I am getting the output. I am getting the output after certain time. Okay. For that time, I am not getting any output. Okay. So, this is known as the dead time. Okay. Or this is one of the undesirable characteristics of an system. I am giving, this is my output, this is my time, and I am not getting any output for this time, and certainly after certain time I am getting the output. So, this time when I am not getting any output with respect to my input is called as the dead time characteristics, and it is one of the undesirable characteristics of an instrument. Okay. So, next is hysteresis. The hysteresis is, you already know the what is the hysteresis curve, and we will see that what is the definition of the hysteresis. The hysteresis is non-coincidence of loading and unloading curves on the output side. So, when we talk about the hysteresis, it shows the physical, chemical or the electrical phenomena when input increases, output also increases, and calibration curve can be drawn if input is decreases from maximum value and output also decreases, but not follow the same curve. It is known as the hysteresis, and because of this, which error cause is known as the hysteresis error. So, what is hysteresis actually? I am increasing the input I am increasing the input and I am getting the change in the output side. This is my output and this is with respect to time. But when I am decreasing the input, it should follow the same curve, but it is not follow the same curve, it follows certain other curve is known as the hysteresis. If I am giving input like I am linearly increasing the input and I am getting the output, and output is increasing when I am increasing the input, but when I am decreasing the input, output not follow the same curve is known as the hysteresis, and because of which the hysteresis error causes in an instrument. So, this type of error is known as the hysteresis, in that when I am increasing the input, output increases, but when I am decreasing the input, output does not follow the same curve is known as the hysteresis error. So, the difference between the increasing change and the decreasing change of the output value is known as the hysteresis error. Now, next is backlash, the maximum distance through which one part of the instrument is moved without disturbing the other part. Okay. So, this is known as the backlash, or it may also be defined as the maximum distance or the angle through which any part of the instrument can be moved without causing any motion of the next part of the system. So, this is known as the backlash, that I can move or one part of the instrument, but without disturbing the other part of instrument. This is known as the backlash. Now, next is reproducibility. Reproducibility is defined as the ability of an instrument to produce the same output for repeated application of same input under different environmental condition. Okay. Now, there is a difference between reproducibility and repeatability. It is very common question. Okay. So, what is reproducibility? If I am taking any reading from an instrument, okay, in one environmental condition, okay, and I change the environmental condition and I am getting the same reading, is known as the reproducibility. But I am getting the same reading again and again in same environmental condition. Okay. So, that is known as the repeatability of the instrument. Okay. So, if environmental changes are there and I am reproducing my reading again and again from an instrument, is known as the reproducibility, and when I am getting the same reading again and again from an instrument with same environmental condition, is known as the repeatability of the instrument. Okay. Next one is the threshold. Threshold is the minimum value of input which is necessary to active or to get the active change in the output side. The motorcycle or the motorbike or the scooty is the example of threshold. If we start our bike or start our scooty and there is a certain limit from which we move the accelerator and we get output on the our vehicle moves. So, there is a certain minimum reading that requires to get the active change in the output. This type of characteristics is known as the threshold. Next is input impedance. So, the magnitude of the impedance of element connected across the signal source is called the input impedance, and the input impedance of ideal system should be infinite. Now, next one is loading effect. I have talked about the loading effect in earlier lecture also. Loading effect is the incapability of the system faithfully measure, record or control the input signal in accurate form. So, it is also one type of undesirable characteristics of instrument that will cause with respect to the load change or with respect to the load of an instrument. So, this type of error is known as the loading effect. Next characteristics is drift. A drift is an undesirable change in output over a period of time that is unrelated to the change in input, that will be with respect to the operating conditions. A drift is occurred in an instrument due to internal temperature variation. okay, or any environmental changes. So, what is drift? There are maybe 3 types of drift we can see from the graph. You can see from the graph. First is zero drift, second one is span drift, and third one is zonal drift. So, when we talk about the zero drift, this is our input line, this is our input line, and this is our output line. So, output does not follow the input, and we have talked about the various characteristics in that linearity is there. So, output is not following the input. So, this type of characteristics known as the zero drift, because the output is parallel to the input. And when we talk about the span drift, what is span drift? When there is a angle between the input and the output, but output does not follow the input. This is known as the span drift. Okay. And when we talk about the zonal drift, so zonal drift, what is zonal drift? In the zonal drift, we are having the change in certain part of the output. This type of drift is known as the zonal drift. So, this is all about the drift. Next, what is static error? The static error is the difference between the true value of measuring quantity to the value shown by the measuring instrument under not varying process condition. So, the static error is the difference between the true value of measured variable and the instrument reading. That may be positive static error means instrument reads high, and the negative static error means instrument reading is low. Now, what are the dynamic characteristics? I have already told you which belongs the characteristics which belong to the transient part of system, or the part which is varying with respect to time is known as the dynamic characteristics. So, to know or to measure the dynamic characteristics, we can use the step input, we can use the linear input or the step signal or the ramp signal, or we can use the sinusoidal signal. That is depend on our application. So, that is known as the dynamic characteristics of instrument, and there are various dynamic characteristics. First is speed of response, second is fidelity, third one is lag, and fourth one is dynamic error. So, the speed of response, with respect to time we are getting the change in the output or the transient in the output. If it is fast, the speed of response is fast. If it is low, speed of response is low. Next one is fidelity. It is the degree to which an instrument indicates the change in the measured variable without dynamic error. Okay. So, that is known as the fidelity. And next one is the lag. So, if I am giving the input and I am not getting the output, so it is one type of lag. So, this type of lag is known as the time delay lag. I am getting output after certain time. For this, I am not getting any output. Okay. So, this is known as the lag characteristics. And next one is the dynamic error. So, it is the difference between the true value of the quantity changing with time and the value indicated by the instrument. So, that is known as the dynamic error of an instrument. Now, next is potentiometer. So, potentiometer is a one type of transducer that is used, or the potentiometer is also known the pot or the pot meter, and it is used to measure the displacement in terms of electric voltage. So, it may be called as a one type of electric transducer. Okay. And it is a passive device because it operates with respect to the certain external voltage, and potentiometer can be also used as a voltage divider. Okay. So, there is a, if you see the diagram, this is our input voltage and this is our resistor and this is our sliding contact. So, by moving this sliding contact, we can change the output voltage. That is why a potentiometer can be used as a voltage divider, and by varying this sliding contact, we can also measure the displacement in terms of, we can get the displacement in terms of output voltage. So, it is known as the potentiometer. Now, we can use the resistance over there. So, there may be two type of resistance, this type of load we can use, or this type of load we can use in the potentiometer. meter. So, I have already told you about the construction and the working of the potentiometer. In that diagram we can see over here that this is my input voltage and this is my sliding constant and this is distance x. I am getting this distance x in terms of output voltage. From galvanometer I will know my reading on the output side. If I am slightly move this contact, now this is x, suppose I have moved this contact to this position, okay, and that reading I am getting x dash. So, the displacement I am getting the certain change when I am done this into x dash, I will get that reading with the help of galvanometer on the output side. So, the potential work of potentiometer is to give you displacement in terms of electric voltage, or it can also be used as a voltage divider. So, there are various type of potentiometer like rotary potentiometer or the linear potentiometer. So, the linear potentiometer is used to measure the linear displacement, rotary potentiometer is used to measure the rotary displacement, and also there are various application of potentiometer that can be used in audio control, television, motion control, or in terms of transducer like for displacement measurement we can use the potentiometer. So, these are certain application of the potentiometer and these are certain type of potentiometer. First is rotary potentiometer, these are the rotary potentiometer which is used to measure the rotary displacement, and these are the wire wound potentiometer. There are various classification which can be used according to the application in the industry. And third one is a trimmer and preset type of potentiometer. These are the slide potentiometer which is having the slide contacts and which is used to measure the linear displacement. Okay. So, this is all about the potentiometer. Thank you.